All right, now let's implement the remove method. So public void removeAt. We give it an index. Now, what should we do here? First, we want to validate the index and make sure it's within the right range. For example, if someone passes -1, it doesn't make sense. What does it mean to remove the item at index -1? Or let's say our array has 5 items. As you know, the index of the last item, in this case, should be 4. What if someone says, remove the item at the index 5 or 6 or 7? Again, it doesn't make sense. So first, we want to validate the index. Second, we want to shift the items to the left to fill the hole. We'll talk about what this means in a second. Let's implement each of these scenarios one by one. So first, we're going to validate the index. This is pretty easy. We can write an if statement like this. If index is less than 0, or we use 2 vertical bars to indicate a logical or index is greater than or equal to count. What does this mean? Well, if count is 4, that means the index of the last item is 3. So we cannot tell this array to remove the item at index 4 or 5 and so on. So that is why we have greater than or equal to count here. Now, what should we do in this case? We don't want to print a message on the console because this class might be used in an application with a graphical user interface. There, we don't have a console. So instead, we should throw an exception because this is a programming error if someone passes an index that is out of range. So by throwing an exception, we force the program to crash. And with this, the programmer knows that they made a mistake and they will solve this problem. So we throw a new exception of type illegal argument exception. That was the first step. Now let's work on the second part. Let's imagine we have an array like this, 10, 20, 30, and 40. And then we want to remove the item at index 1. That is this 20 over here. So in order to remove 20, we should copy 30 over here and then 40 over here. So we're shifting each item one step to the left. In other words, the item at index 1 should be set to what we have at index 2, and what we have at index 2 should be set to what we have at index 3. How can we implement this? This is very easy. We need a for loop that starts from this index, and it goes all the way until it reaches the end of this array. So for int I, we set this to index. As long as I is less than count, we increment I after each step. Now in each iteration, we want to set the item at this index to the item to its right side. That is pretty easy. So we set items of I to items of I plus 1. Okay? So after we execute this for loop, our array is going to look like this. 30 is going to be copied over here, and then 40 is going to be copied over here. But we still have 4 items in this array. We want to shrink this array so it looks like this. How can we do that? Very easy. After our loop, we decrement count by 1. Because count represents the total number of items currently in the array, not the size of the array, right? So let's test our code. Back to the main class. We added 4 items here. Before printing the array, let's call removeAt and remove the first item. So 10 is going to go away. Now we have 20, 30, 40. Beautiful. Let's test it with a different index. Let's say index 1. Now 20 is gone. Beautiful. Let's do another test and remove the last item. So we pass index 3. 40 is gone. What if we pass index 4? We got an exception of type illegal argument exception. This is a programming mistake. We don't want to print a message on the console. We want to stop the execution of the program. So now that we're done with the implementation of the remove method, let's get rid of these unnecessary comments and make our code clean. Next, we're going to implement the search operation.